Welcome to Chapter 2, Section 1, the Python Interpreter. By the end of this section, students will understand how to use Python shell for cybersecurity tasks, including experimenting with exploits, analyzing logs, and testing network connections. We'll explain how Python's interpreter helps cybersecurity professionals by providing immediate feedback, making it ideal for testing exploits, debugging payloads, and writing quick forensic or detection scripts. We'll also demonstrate how command history reduces repetitive typing and highlight how this speeds up exploit testing, payload tweaking, or quick reruns of log parsing commands. Let's jump into an example and see how we can use the socket library to make a quick banner grabber. We're going to jump into Kali Linux here, and we'll jump into the Python interpreter. Just type Python 3, and now we're in the Python shell. You can see I'm running Python version 3.13.5. First thing we want to do is go ahead and import the socket library, and then hit enter. Now that has executed this command. So the next thing we want to do is create a socket. So S is our variable. We'll use the assignment operator followed by socket opening parentheses. So we're calling the function to create a socket. We're going to pass in socket.af inet. This is a constant. Then we'll pass in another parameter, and that is socket dot sock underscore stream. And now we can print S, and you can see it's a socket. We've created a socket so far. Now we haven't connected to anything yet. So let's go ahead and connect to a destination on a port. So we'll use port 80, and we'll use scanme.nmap.org, so we can do s.connect, and then pass in a tuple for the domain name or IP address. So we'll do scanme.nmap.org, and we're going to connect on port 80 and go ahead and hit enter. Now we're connected. Then we can actually send some bytes. So let's do s.send. We'll call the send function, and that'll allow us to send some bytes across the wire. Now we need to make sure we're sending bytes, so I'm going to use B for bytes, then double quote, and then we can send a GET request. So I'm going to get the root right here, and then we're going to use HTTP version 1.1. with a new line, and then we'll do the host, and that's scanme.nmap.org. And then we want 2 new lines. And then the next thing we want to do is receive bytes. So we'll do response receive, and we'll receive 1024 bytes. And actually this is responses are variable, so equals s.receive 1024 bytes, and we can print response to see what we received. Now we received this back. Now we can actually, it's in a bytes object, so we can literally decode it. So let's print response.decode. Yeah, and you can see the structured. So here's the response header. We got a 200 OK. We also got the HTML from the site itself. Now, after that, we want to close the socket. Now we're all done. And that's an example of using the shell just to run through command by command to actually connect to scammy.org on port 80. There's a lot of things you can do with the socket library. You can use it to make a banner grabber, or you can use it to send custom payloads for exploit development and so forth. So go ahead on your own, experiment with that socket activity we just did, and maybe change the port to port 443 and see what happens, or port 22 and see what happens. See if you can send a custom message with s.send. Also adjust how many bytes you capture to see what the result is, and make sure you close the socket when you're done. This will prevent resources or memory leaks. In the next lecture, we'll jump into type conversion.